All right, sorry about that earlier. I'll show you what the mistake was when I get to it. I mean, I was doing everything so far so great, except I forgot to put the bounds, and I had to convert those first. But let's go ahead and redo this one. Okay, so let's find the volume, where the volume is the triple integral. We're going to do our dz, dy, dx. So our picture we drew earlier, that's our y, that's our x, and this is our z. So and so find the volume of the region split the surface this. Well, we had two parts. We had to first let's set them equal to each other so we can find out what our bounds are with respect to x and y and z. So our first part we have c x squared plus 3y squared is equal to 8 minus x squared minus y squared. Move everything to one side. So we add x squared and we add y squared to both sides. Those cancel, which gives us 2x squared plus 4y squared equals 8. They're all a factor of 2, so we can divide by 2. So x squared plus 2y squared equals 4. So it's an oval type shaped object. All right, so this is r squared. So r squared equals 4, so r equals 2. Well, plus or minus 2, because it's when we take the square root of it, we take the plus or minus square root of 4, which is equal to plus or minus 2. Okay. So now we have one of our equations. So the first integral we're going to look at is dz, then dy, then dx. The z, it's going from both of the two original equations. That's z1 and c2. So the easiest way to do it is if we set x and y both equal to 0, which one's on top? This one's on top. So it is our upper bound. And this is our lower bound. You know, suppose z has to be in terms of x and y. Okay, now we have this formula here, which is just only of x and y. We solve that one for the y components. Solve for y. So we have 2y squared equals 4 minus x squared divided by 2. Or minus x squared divided by 2, and we square root both sides. So y equals plus or minus square root of 4 minus x squared. So these are my bounds for the y-axis. Negative square root of 4 minus x squared over 2, and positive 4 minus x squared over 2. All right. If we set y equals 0, so we see what we're doing on x and y. If we set y equals 0, we have x squared equals 4, so x equals plus or minus 2. So those are our bounds of integration, and our function is equal to 1. So the first step with respect to z, so the integral of 1 it's the writing part's going to be the worst. So integral of 1 is z, and it goes from 8 minus x squared minus y squared to x squared plus 3y squared dy dx. Let's just go ahead and write what we have so far. Okay, so first we have 8 minus x squared minus y squared minus the bottom, which is x squared plus 3y squared dy dx. Let's go ahead and simplify this one. We have 8 minus x squared minus y squared minus x squared minus 3y squared. So we have 8 negative x squared, so it's negative 2x squared. Negative 1, negative 3, so it's negative 4y squared. All right, so that's what all this simplifies into. So far we have this. Nothing new or nothing out of the ordinary. So we have 8 minus 2x squared minus 4y squared dy dx. Okay, so now we have to take this next bound with respect to y. Negative 2 to 2. All right, so each one of these, the integral of 8 with respect to y is 8y. 2x squared with respect to y is 2x squared y. And then 4y squared is 4y cubed over 3. From negative radical 4 minus x squared over 2 to radical 4 minus x squared over 2 dx. I don't lose it. All right, now we gotta do the bounds. So the first one is 8 times radical 4 minus x squared over 2. Actually, since these are both x and y's, we can just go ahead and combine both of those. That's okay. We'll just do it this way. Just means more writing for me. And then minus 4 over 3. 4 minus x squared over 2 cubed. So that's the top one. Minus the bottom one. So we have 8 times negative 4 minus x squared over 2 minus 2 x squared times negative radical 4 minus x squared over 2 minus 4/3 negative radical 4x squared, 4 minus x squared over 2. And then we have to do it with the x at the end. So this one goes, the sign goes out in front. This sign changes that to a plus. This sign changes this to a plus. Now I can distribute this negative sign through there. This negative sign changes this one to a plus, changes this one back to a minus, and that one to a minus. So all these are gone inside here. So we have 8 and 8, which makes it 16 radical 4 minus x squared over 2. Negative 2x squared makes it negative 4x squared radical 4 minus x squared. Minus 4/3 is minus 8/3. Radical 4 minus x squared over 3 cubed dx. Okay. Now go ahead and combine these two. So we have 16 minus 4x squared. Radical 4 minus x squared over 2. Four minus x squared over 2, not 3, where I got 3 from. Cubed. Because now I get this. If we look at this one, if we factor out a 4 out of this one, we factor out a 4, then we get 4 minus x squared. Okay, now what this looks like this. Oh, if we divide it by 2, we can do that if we multiply by 2 out here, because the 2's are canceled. So we have 8 4 minus x squared over 2 radical 4 minus x squared over 2 minus 8/3 radical 4 minus x squared over 2 cubed. these are the same now because this one is an exponent 2 over 2. This one is an exponent 1 over 2. So if I put these two together, I got 4 minus x squared over 2 to the power 3/2 minus 8 over 3, 4 minus x squared to the 3/2. So far, so good. Because now we can combine these. Well, this one's going to be, this is 8 over 1. So to get a common denominator, I can multiply top and bottom by 3. Which gives me 24 over 3 minus 8 over 3, 4 minus x squared over 2 to the power 3/2 dx. (24 minus 8 is 16 over 3. The 16 over 3 is a constant, so I can bring it out in front. Now, I got to worry about what's inside the radical. I mean, the integral. So I can split these up. I can distribute this top and bottom because this is also going to be a constant. Two and 3/2 is 2 radical 2. So that can bring out in front. Two radical 2. All right, so I get rationalize the denominator. So I got 16 over 3 times radical 2. Radical 2 is 2, so it's 4. So the 4 and 16 cancel. So we have 4 radical 2 over 3. And the integral of -2 . Now this is where the problem begins. This, we have to use substitution. We're going to say that x is equal to 2 sine u. Now when the dx part will equal to 2 is a constant. Derivative of sine is cosine du. Okay, that's only the first part. Now we also have to, since we're changing the x to u substitution there, we also have to change the bounds. In other words, we'll use this one here. So since x is 2, let's see what the upper bound is going to be. So we divide by 2 both sides. And take the arc sign. So the upper bound is the arc sine of 1, which is pi over 2. And the other one, we put -2 equals 2 sine u. And work that out. We get -1. So we say the second one, the lower bound, is arc sine of -1, which is negative pi over 2. So our bounds are now going to be from negative pi over 2 to pi over 2. Because now we're doing with respect to u's. Now, the next thing we have to do, here are our trig identities that we're going to be using. So we have sine squared x plus cosine squared x equals 1. The double angle sine x is the same thing as 2 sine x cosine x. If I had sine to the 4x, that would be sine 2 sine 2x cosine 2x. The double angle of cosine is cosine squared x minus sine squared x. Cosine squared x can be written as, besides 1 minus sine squared, it can be written as 1/2 1 plus cosine 2x. And cosine squared, the double angle, is equal to 1/2 1 plus cosine 4x. Those are the ones we'll be using now. So we'll start off, we'll bring this in later on, so it saves on writing. This is the only thing we'll be looking at now. But yeah, we'll bring this back at the end. Negative pi over 2, pi over 2. So we have to convert this. Well, we'll leave it at -2 for it now because I'm still in terms of x's. So I have, remember earlier I said that x is equal to 2 sine u, and dx is 2 cosine u du. So this gives me 4 minus x squared. So if I square this, I get 4 sine squared u. Dx is 2 cosine u du. Now I'm going through my bounds of negative pi over 2 to pi over 2 since I've done this conversion. So first I can factor out, well, I can distribute, I can factor out of 4. So what I'm going to have here is 4 times 1 minus sine squared u, and all this is still to the power 3/2. I can split them up. So now I could distribute that 3/2 exponent to both terms. So we have 4 to the power 3/2, 1 minus sine squared u to the power 3/2, 2 cosine u du. So the square root of 4 is 2. 2 to the third power is 8. Times 2. 1 minus sine squared is cosine squared. No, I took that 2. Cosine u du. So what do I have now? 8 times 2 is 16. The square and the square root disappear. So this becomes cosine cubed times cosine, makes it cosine to the 4th u du. All right, this is a constant. Let's take it outside. Now in our identity charts, what do we have that we could do this with? So this can be rewritten I just forgot to put the bounds on in our example earlier. So I could convert this one to cosine squared u squared du. All right, let's look at what cosine squared is in our tables. Cosine squared is 1/2 1 minus cosine 2x. But it's all squared, so 1/2 1 plus cosine 2u squared. Du. Let me write what I have here. So this square goes to this one, so it's 1/4. And it stays on top of this. So this 4 and this 16 can cancel. One plus cosine 2u squared. Go ahead and FOIL this one. negative pi over 2 to pi over 2. So this is going to be 1 plus cosine 2u, 1 plus cosine 2u, which is 1 plus 2 cosine 2u plus cosine squared 2u. du. So let's distribute this radical, I mean the integral sign to each term. To cosine 2u du. But what we have to do, because before we could really plug these in, we have to put them so they're easily integrable, that we don't have to use any other rules about that. So the integral of 1 du is u from pi over 2 to negative pi over 2. 2 cosine 2u, the integral of that would be sine 2u. Because the derivative of sine is cosine, derivative of 2u is 2. So that's perfect there. Now, the only one that's going to give us any troubles is this last one. Because cosine 2u is the same thing as, that's an old one. Where's a new one? Cosine squared 2u is 1/2 1 plus cosine 4x. Was cosine squared 2x is 1/2 1 plus cosine 4x. 1/2 cosine, no, 1 plus. Yeah, cosine squared 2u is 1/2 open parenthesis 1 plus cosine 4u du. So the 1/2 comes out in front. And then I could split both of those. One du cosine 4u du. Okay, we're almost there. You could have worked these first two out earlier if you wanted to. I like to do them all at one time at the very end. So this one is u. So the integral of this one, I need to have a 4 in front. If I have a 4 there, I need a 1/2 in front. So the integral of 4 cosine 4u is sine 4u. Well, this first one, we have pi over 2 minus negative pi over 2 plus sine 2 pi over 2 minus a negative sine 2 pi over 2. Pi over 2 minus negative pi over 2 plus 1/4 sine 4 pi over 2 minus negative sine 4 pi over 2. This becomes a plus, so pi over 2 makes it pi. The 2's cancel, so sine pi is 0. Those cancel, sine pi is 0. Pi over 2 plus pi over 2 is pi. Two pi to 2 and 4 cancels. Sine 2 pi is 0, 0. So that one's 0. So we have 4 pi over 2. This makes it 2 over 2, so it's 3 pi over 2. Which cancels that. So we have 6 pi here. Plus our coefficient earlier was what? 4 radical 2 over 3, I believe. Yeah, 4 radical 2 over 3 times 6 pi. 3 cancels a 6. So we have 2 times 4 is 8 pi radical 2. Yay. I am sorry about the brain fart earlier. All right. Good luck, everybody.